So hello, everyone. Welcome to the webinar. This NEXUS Gains webinar is about spatially explicit approaches at the food, biodiversity, and climate nexus. With biodiversity decline and climate change, two of our biggest global challenges at the moment, we need to find solutions for reversing trends against biodiversity and against climate change, alongside producing food and other resources for human consumption. The CGIAR NEXUS Gains initiative works on finding science-based solutions at the food, biodiversity, and climate nexus. And we work with our local partners to help design effective, culturally appropriate, and scalable interventions at multiple levels. We organize today's session to help stimulate dialogue and advance discussions and science in this space, particularly in light of the Global Biodiversity Framework, which was signed last year, and targets 1 and 10. Through these targets, countries have committed to biodiversity inclusive spatial planning for achieving their global goals. And they've also committed to shifting to biodiversity friendly and agroecological food systems. And countries are now in the process of deciding how they can actually do this. This is really a nexus challenge and requires place-based systems thinking. So I am pleased today that we'll be hearing from two scientists about spatially explicit approaches that they've been deploying related to multi-objective target attainment. We'll also be hearing from two experts on our panel, reflections on how scientists can better support decision makers through spatially explicit approaches. For our listeners, if you have questions or comments, can you please write them in the Q&A chat? We won't be able to unmute you, so I will read out the questions after our presentations and panelists have had their chance to speak. So without further ado, I will introduce our first presenter. This is Sarika Mitra, a postdoctoral researcher with the Alliance of Biodiversity International and CGIAR, based in India. Sarika is a spatial data scientist and agroecologist. She's currently working to finalize a threat and opportunity hotspot planning tool as part of the Agrobiodiversity Index, among other activities. So Sarika, I pass over to you.
Hello, I am Sarika Mitra, and I will be presenting the research that my colleagues, Natalia, Sarah, and I are doing on threats and diversity-based solutions, hotspot mapping for sustainable food production. Now, our objective is to identify spatially explicit areas where agricultural landscapes are facing one or multiple socio-ecological threats to sustainable food production, and then to rank these threats so that we can identify where urgent action is required. Once we have identified these areas, we can characterize diversity-based interventions that are specific to the threat and the location. But why are we doing this? Similar studies have been done before, and I would like to point to one of the recent studies. The foodscapes mapping is an excellent research that was published this year. The authors have mapped foodscapes globally and even calculated how much pressure exposure these foodscapes are facing. But for most of these studies, they lack the granularity that we are aiming for and does not include social component as a driver to these threats. So how did we conceptualize our research? We know natural resources like soil, water, air, etc. are critical for production systems. We know that a higher diversity, for example, maintains and enhances the health of the system. But when the variables within these components face depletion or degradation, the system faces a risk. These are further compounded by the negative and positive feedbacks from climate change. And both natural resources and climate risks interact with human well-being that reinforces the threats and increases the vulnerability of the system. So, what is the solution? Research has shown that conserving and restoring agrobiodiversity is a solution to maintaining the health of the system and reducing the risks. If we can show where the threats occur and specify these threats, then we can guide policymakers on how to reduce these threats. So this is the workflow of our methodology, and I will walk you through each of them. We started with a review of threat methodology, where we did a systematic review of the threats and how to combine spatial layers. We reviewed more than 1,500 peer-reviewed articles, selected and screened them to extract relevant information about methods, hotspot analysis, selecting thresholds, etc. When our review was completed, we started creating our database. So this is a meta-analysis, and we wanted published datasets that were relevant to all the indicators in our conceptual framework. We looked for quality and coverage in the data, the license to use. Until date, we have curated about 230 datasets that describe some aspect of agriculture, biodiversity, land cover, land use, soil, water, vegetation, etc. Once we had curated enough datasets to characterize most of the threats to our 5 components, that is water, environment, food, energy, and social, we started screening the data. Is this relevant to our study? Is it too old? Some data sets are specific threat layers, like land degradation, for example, and we assigned it to the relevant component, environment in this case. While others, like observation data for climate variables, need to be converted to a threat layer before being assigned to a component. So the next step was to set the data thresholds. For each indicator, we chose the threshold value using a precautionary principle, that is, selecting the most conservative value. For example, the table on the right, it shows the permissible limits of drinking water quality as specified by 5 agencies. The 3 columns on the right, they are from Indian agencies. If, for example, the layer is the concentration of chlorides in water in India, we would still be choosing a threshold value of 200 mg per liters as specified by the WHO and not that of either of the 3 Indian agencies, because the WHO value is the most conservative. So we set the threshold value to create a threshold layer for each indicator. And depending on the data, it can be a binary layer like presence or absence of threat, a score between a minimum and maximum range, or a category like low, medium, high, etc. I'll demonstrate with one example. This is a map of the baseline water stress risk categories from WRI, the World Resource Institute, Aqueduct 4 dataset. The minimum threshold of risk, according to Aqueduct, is when BWS falls below 10%. If we apply that threshold and convert this layer to a binary no threat layer, then this is what our BWS threat layer looks like. And you can see almost all of India is under water stress at some level of threat. Applying the same principle, these would be the results for threats faced by indicators like surface water BOD, land degradation, or intact landscapes. So then we combine these threat layers to identify hotspot areas and we propose to run 3 different methods. As this is a meta-analysis, there are redundancies between the threat layers because of how the original layers were analyzed and processed. So first, we'll do a simple overlay analysis combining all the layers. Second, we propose to run a principal component analysis. This will help reduce some of the noise and the dimensionality and identify multicollinearity. And finally, we'll run a spatial cluster analysis to identify the spatial patterns of threat occurrence. We'll have spatially explicit hotspot maps that will identify vulnerable areas. These will define the number and level of threats and the contribution of each indicator to the overall threat. We'll also have component-wise hotspot maps, which can be more context-specific and easier to interpret by policymakers. For example, when we go visit a certain ministry which handles a certain component, this would be easier for them to visualize and interpret. So this is an example of a hotspot map that I did using an overlay analysis with some threat layers that are mentioned on the right. I set the thresholds, normalize the data, stack them, sum them, and normalize the results so that the threat score is between 0 to 1, 1 being the highest level of threat. We see that most of India is facing medium to high threats, while areas of low human habitation, that is up there in the mountains, the Himalayas, or here in the desert, these are the areas where generally the threat is very low. But the question that come up is, are the spatial patterns correct? Did we miss something that we should have included? Are there issues that are hyperlocal? So to answer these questions, we move to the final step of our workflow and the final slide. We need to validate the results to co-design local solutions with expert input that will also be context specific. We also intend to have an interactive online tool for intervention planning. And this is not just aimed for policymakers, but also for other interested users. The tool will be both for visualization. My tongue is twisting now. Where is a specific threat, or if you want to see a combination of a threat which is combined with two different indicators. We will also make it interactive. For example, if a user is interested in adjusting the threshold for one or more specific indicators, if a policymaker, for example, wants to find out how the threat level will change with his proposed adjustments. So this brings me to the conclusion. This was an update on the hotspot mapping analysis, from our objectives to our conceptual framework to the design of our methodology, along with a few examples. I hope you found it interesting, and I will wait for your questions. Thank you very much for listening. I hope I'm within the time. Farah, on to you.
Bang on time. Thank you very much, Sharika. And for the listeners, do remember to type your questions into the Q&A, and we'll pass them to Sharika at the end of the session. So our second speaker is Federico Frank, a modeler and agricultural scientist from Argentina. Federico is part of the FABLE Consortium, which is a network of food and land use system modelers and researchers. Until recently, Federico was at the National Institute for Agricultural Technology, INTA, in Argentina, and a member of the FABLE Argentina team. Now he's also part of the FABLE coordinating team since moving to a new post at IASA in Austria. Federico leads the FABLE calculator modeling for Argentina, and he'll present his team's experience making the outcomes of this model spatially explicit to support long-term national food and land use strategies. So over to you, Federico.
Thank you for the invitation, and thank you, Sarah, for the introduction. I will try to present in the next 10 minutes the lessons we are learning up to now, and we still learn in Argentina in this linkage between food, biodiversity, and climate change. So first, the idea behind all this is how we can use science to help the government, the Argentinian government, to write their long-term strategies, particularly in terms of low emissions development. And what I will present is the results from 3 projects, some ongoing and some finished. And the overall objective of this, or the shared objective of these projects, was to help the government in derive their own long-term strategies for low emissions through modeling and through interaction with stakeholders. So we start from the idea that in the past in Argentina we've had some emission inventories and that we need to lower them if we want to comply with agreements such as the Paris Agreement. And being Argentina such a big country with different areas and different realities, we agreed, the members of the projects and the stakeholders, we agreed that a visual representation of this future modeling would be very important for stakeholders and for the ones who make the decisions. So we agreed that if we didn't do anything regarding climate change, we may end up in a business as usual scenario, and that there were any number of different scenarios in terms of ambitions regarding climate change, and that those scenarios may or can be linked to coherent representation of land use and land covers. With that in mind, we started by meeting with stakeholders and conducting workshops. We call them scenarists because we used them to get information for the modeling work, and we shared the modeling results in a series of workshops that were cut off because of the COVID pandemic, but we did what we could with what we had. Through the workshops with the scenarists, we gained all the information and we constructed the narratives for the scenarios. We started with 4 scenarios and we ended up with only 2, the business as usual scenario and the carbon neutrality scenario, which was the ultimate objective of the modeling work. And for this modeling work, we used 3 models. One is the Fable calculator, which is like the core model of the Fable consortium, one of the participants of this process, which in very few words, it allocates land use and food production and consumption at the country level without being spatially explicit, and provides a series of indicators. We use from this model the greenhouse gases emission indicator, which was like the ultimate objective to reduce, and the land use indicators, the evolution of the different land uses and land covers, which were also important for the sector. These are the results of just to see examples of in the right, the business as usual scenario, which could lead us to more than 250 megatons of CO2 equivalent per year, only from the AFOLU sector for the country, double of what we emit these years, and which would also lead to an increase in an expansion of crops and an expansion of pastures. And to the right, the carbon neutral scenario, which is not strictly neutral because we could reach like around 7 megatons of CO2 equivalent per year, and a scenario that reduces the pasture and maintains the cropland areas in the country. But this is all modeled without the ability to provide maps for the stakeholders to really see what would this mean in space. So we linked the results from the calculator to another model called Dinamica Ego, which uses known distribution of land uses to construct a transition matrix between the starting time and the ending time, which for our case were the year 2000 and 2020. And through a series of explanatory variables, we construct a model explaining land use changes in this period, and provides a projection of land use to any year in the future, which would be consistent with the business as usual scenario. What we did is to extract the land use changes from the Fable calculator, and we we had a different land use matrix or transition matrix, or as many transition matrix as scenarios we want to see. And we were able to show the stakeholders what each scenario would mean in land use terms. And in between all these discussions and ideas, came also a different project that was called Nature Map. And the objective of this project is to identify and prioritize the best areas to protect in order to protect multiple assets for the country. In our case, we use biodiversity, water provision, and soil and biomass carbon stock. And through this model, which I will not explain because of the time, we found the best areas that should be protected if we wanted to protect all these three assets at once. And with this, we constructed a projection of what would be the protected areas with different levels of ambitions, of course. In Argentina, the current land area protected is less than 7%. And this would be the map if we wanted to present, the one in the middle would be the map if we wanted to protect 17%. And the one to the right is the map if we wanted to protect 30% of the area and maybe comply to a 30 by 30%. And with this, we also created maps of what would be the impact on biodiversity of such scenarios and could compare. And with the combination of the three models, which I will explain in the next slide, we created like a third scenario, which is a carbon neutral, sustainable, or sustainable carbon neutral. We call it that because we couldn't find a better name. And it's like a scenario that is both carbon neutral or close to carbon neutral for the AFOLU sector in Argentina, but also protects biodiversity, water provision, and soil and biomass carbon in the ecosystems. And the idea is the linkage between the models is in this process is we started from the stakeholder consultation, but we wanted to have more workshops once we had the results, and we couldn't do that because of COVID, but we did it bilaterally and by mail and by Zoom. And we got information to construct the scenarios in the Faber calculator. We used the results from the Faber calculator to specialize these scenarios, and we used Nature Map in order to identify the protected areas. Then we used these protected areas at different times, like restrictions to land use changes in dynamic aego, and we also used all these results as a validation of the scenarios constructed in the Faber calculator. And the outcome of this process was a series of policy briefs that we gave the government in order to help them to construct their LTS and their future NDCs, for example. This is another example of the kind of results. Consistent emissions for the country, or actually for the AFOLU sector of the country, with consistent maps of what would mean in terms of land use and land cover. And the idea is this linkage between the models, these iterations between the models that we join or we constructed in this process. And to return to where we started and to finish the presentation, in parallel, to all this process, we ask the stakeholders about what it would be needed or how we could achieve these results that the model only show that it's feasible in biophysical terms, for example, but may not be attainable in political or in economic terms. So we found out from this consultation that the business as usual and what we now call current trends, but it's the same idea. It's in a scenario determined, but what is most likely going to happen in the future, it's coherent with current policies and it's also economically viable, but not at all ambitious in biodiversity and in climate change terms or in low emission terms. And the other one is a scenario that is biophysically feasible, possible to achieve, as it was shown by the modeling results. It's climatically and ecologically sustainable, but sadly, it has little consensus among stakeholders and actors. And in between these two extreme scenarios is the discussion that we are supposed to continue in the future between the government, the stakeholders from the follow sector, and the modeling team, not in the air, but with the help of the results of this modeling exercise. And I think I'm run out of time, but I think I ended my presentation here.
Excellent. Thank you, Federico. And you managed to make something that is really complex look quite simple. And that's a talent. So great job. To kick us off with some initial reflections, let's turn to our panelists. So we're joined by two panelists, and the first that I will turn to is Carolina Navarrete-Frias. She's a senior policy advisor with the Alliance. And Carolina, your work includes interacting with national policymakers who are updating their national biodiversity strategies and action plans for the global biodiversity framework. Can you share some insights with us about how spatially explicit approaches can support this effort that they're going through at the moment, and how researchers can integrate with the process?
Thank you, Sarah. Good morning, everyone. So I'll briefly share my screen. I had some reflections related to your query coming from our interactions throughout years in the negotiation of the Global Biodiversity Framework. And then when it was approved, it's now more in the process of the implementation of the Global Biodiversity Framework. So yes, it's from the perspective of putting this into practical terms and how to support the implementation of the Kunming-Montreal Global Biodiversity Framework. So some reflections and ideas here, just to share with the audience that there was the recent meeting in Nairobi was the SUBSTA, which is the subsidiary body that provides technical advice to the countries and the CBD for the implementation of the Global Biodiversity Framework. And there was actually a collection of inputs that was sent to countries to understand better what were their scientific and technical needs, right, to support the implementation of the GBF. And this was a very interesting process to be part of, actually, in terms of hearing what countries had to say, because it will allow us to be more demand-driven. So this, as I said, these were country consultations. Over 100 countries participated. And we wanted to know more the gaps, right, and the tools and guidance needed. So some of the key findings are here, and I'm sharing them with you. And there are gaps in tools and guidance to support the implementation of the GBF. And what I found that was quite interesting and very related to the topic that we're addressing today is that they highlighted that there is potential for new work in an area on biodiversity inclusive planning. So let me now refer to the GBF. And here is just to share with you a very good website that has guidance notes with all the targets. And there is target 1. And as Sarah was mentioning right at the beginning, there are several targets that are relevant for spatial planning, but target 1 is actually the one that has been referring to this especially. So it's plan and manage all areas to reduce biodiversity loss. And as you can see here, the description is ensure that all areas are under participatory, integrated, and biodiversity inclusive spatial planning and under effective management processes. So this is under the radar as a priority, as a global priority for countries, right? Also in the process of updating their NBSAPs, and it's in terms of how to incorporate in their national practices, policies, this biodiversity inclusive spatial planning. So if you go to the same website that I shared before, let me just move this here. The CBD has done a great job, and you can see tools and guidance for implementation. Something that got my attention there is as you kind of scroll down on the tools and guidance, most of them are on marine and maritime spatial planning, which I think is good in terms of thinking, okay, there's a strength there. But if we're thinking about this from a Nexus approach, there was not really a lot of tools or guidance connecting to other areas or with a Nexus focus. There was only this one that I found, that is the Integrated Spatial Planning Workbook. Of course, it's important to highlight things that we could build on. It's not to say there is nothing out there, but it's important to also identify the gaps. So if we're thinking how we can support the spatial explicit approaches at the food biodiversity climate nexus. So definitely it's important to provide more evidence and clarity for practitioners and just policymakers in general, local communities on biodiversity inclusive spatial planning from a nexus perspective. From the discussions I participated in throughout the years, I think there is a gap of knowledge still in terms of understanding what that refers to and how you apply it on the ground. Supporting the use of tools and guidance, the page I just shared with you, to promote the implementation of the global biodiversity framework. Of course, if there are other tools that can provide maybe a nexus approach for this spatial biodiversity inclusive spatial planning, or something that groups could develop to enhance that frontier of knowledge from a practitioner's perspective as well, and backstopping the processes of capacity building and technical and scientific cooperation. So I know you perhaps have heard that before, so the question is how to do that. And here I provide an example. Just recently, the regional and sub-regional technical support centers were approved by the CBD, and at COP16, they'll be meeting. It's a global network of centers, and they'll be developing their action plans. So that's a direct way to engage and provide that support. So thank you very much, and over to you.
Excellent. Thank you, Carolina. So you're calling for more nexus-based evidence and tools and capacity building in country to help countries to use these resources. Really nice. Let's pass to our second panelist, Samantha Hill. So Samantha, you're a conservation ecologist and principal scientist at UNEP WCMC, and your work includes researching human and climate pressures on biodiversity and ecosystem services and assessing the impacts of conservation actions. It would be great to hear from you general reflections, but particularly, what do you think are the risks of using maps for intervention planning to restore biodiversity in agricultural landscapes? And if you have any thoughts on how we can increase the chances that maps lead to positive changes on the ground for both people and nature. Over to you.
Great, thank you very much. Thank you, Sarah, and thank you for inviting me to be a panel member today. Thank you too to Frederica, Sarika, and Carolina for those brilliant talks. This is the risk of going last. I think my answer really echoes the evidence that you've already brilliantly presented today. So thank you very much. So thinking about the risks of using maps, I'm speaking to you today from the Fens of Cambridgeshire, which is a vast low-lying wetland environment with areas that were historically drained for food production. The soil is incredibly rich and very intensively farmed using high-level technology such as robotic planting and harvesting and multiple crops per year that are germinated in these huge stacks in warehouses. Despite this intensive farming, the farms are actually quickly adopting regenerative agricultural practices, including monitoring and maintenance of soil biodiversity, tillage of waste products to increase soil carbon. They use enclosed soil that prevents leaching. And they use complementary planting and artificial barriers to replace pesticides, as well as restoring large areas of natural areas between the fields. So I was really inspired and encouraged by this conversion that's happening, even in these really intensive agricultural landscapes. And I wondered how scientific research could help with their planning. So I went and spoke to one of the farm managers about how they are adapting these regenerative agricultural practices in their farms and planning them for other parts of the world, as they have farms throughout the UK, Northern Africa, and also in Spain. And he looked at me like I was completely crazy. He pointed to the far end of the field and said that he was not able to use the same practices at that end of the field as compared to the end of the field that I was standing in. I mean, it was a large field, but still, when I thought of all the global maps that I had produced for sustainable planning, I must admit my heart really sank. So turning to matters of biodiversity, we also find complexity. We're getting much better at measuring and monitoring multiple aspects of biodiversity. And I think the Best Nature Futures framework has done a really excellent job at highlighting some of the equally important but highly diverse value frameworks when considering biodiversity. What aspects of biodiversity we value, and therefore we want to conserve and restore, are value-driven, and this influences how we measure and what we measure at the local levels. So this is our challenge when thinking about spatial planning on interventions. Biodiversity and agriculture are both incredibly context-specific and value-driven entities. And of course, the goalposts are constantly moving with climate change. When thinking from a nexus point of view, this becomes even more challenging. There's no single right solution. We know that there are trade-offs between nexus elements, and for resilient, just, and equitable solutions, decision-making around prioritization of elements and implementation must occur through consultation with local communities and right holders. However, achieving global and national goals, such as the Sustainable Development Goals, the Global Biodiversity Plan, or national NBSAPs, is both vital and urgent. I won't spend too much time on this, as Carolina has already spoken a bit about this, but to echo the thoughts that we need coordination at global level and national level, as well as coordination across biodiversity relevant boundaries, such as biomes and ecosystems. So plans are vital, the maps are vital, but unless the maps are produced with local context and with recognition of local values and needs, there is a large risk that their utility will be diminished and may even lead to perverse outcomes. Moving now as to how we can increase the chances that using maps will lead to positive changes on the ground. As I mentioned previously, we need to put a lot of thought into what the local goals are and what is the right way to measure those specific aspects, whilst keeping global and regional biodiversity and development goals in mind. And this effort really, I believe, is the key to achieving positive changes that are resilient over time. And this requires effort, a lot of effort. However, as we have seen today in the excellent presentations by Sarika and Frederico, we are getting much better at mapping a variety of aspects. I remember when I started working at UNEP WCMC, like over a decade ago, at that point, many of our maps were at 1 degree resolution. You know, they were 110 kilometer resolution at the equator. I mean, it was just crazy. You can't provide practical advice at that kind of resolution. Even fairly simple models with this blocky resolution took the best part of a day to run. We have come on a really long way. Earth observation data allows us to monitor on-the-ground changes in almost real time. We have better and better maps based on where and how agriculture is operating. And our ability to manage and store data has exponentially increased, allowing the possibility of building all this necessary local and context-specific data into aggregated databases. And modeling has come a long way also. New techniques of AI and deep learning models paired with the revolution in Earth observation data mean that we can produce sophisticated models of previously undocumented taxa or species communities, or that we can look at multiple aspects of biodiversity at the same time. And of course, our models aren't just about monitoring biodiversity. With these new techniques and observational data, as well as with consultation with traditional knowledge holders, we have a much better understanding on the impact of specific management actions on multiple aspects of biodiversity. So again, allowing much better planning. So I think it would be good to conclude with a reminder that we are at a time where I truly believe that there is great hope to be able to tackle multiple nexus issues, including bending the curve of biodiversity loss, as long as we put effort into tackling global goals through implementation with knowledge of the local context. Thank you.
Excellent points from Sam as well. So we've had 4 high quality interventions. Thank you very much. I see that there are actually no questions on the question and answers. So the listeners, over to you, a spotlight now on you to somebody ask a question. I have a few of my own in the meantime, but I'm waiting for the first brave person to put one in there. I'd like to come back to Sarika, and I had a question for you on your presentation. So you're based in India, and what do you think are some of the challenges using maps in stakeholder discussions on biodiversity conservation in India? And perhaps also, what do you see as the priorities for improving spatially explicit threat mapping and therefore intervention planning in the Indian context?
I'll start with your first question about using maps. I mean, maps are great. They are a visualization tool that's everyone uses, everyone loves. It's easy to understand and interpret, but I think that's also one of the reasons that they can be over-interpreted. And there is a list to that. We should be very clear about the input layers and the uncertainties and the accuracy. Just because I'm showing a threat level of 0.5 or 0.7, which is high, I should also include with that there is an uncertainty to that I'm saying this with 50% confidence, or I'm saying this with 70% confidence. So this is also one of the reasons we intend to have component-wise maps. When we are talking to policymakers who are taking care of a specific component like water, the component-wise maps will clearly communicate the threat faced by water quantity, depletion, and water quality issues, and put it in context of the overall threat layer. And I'm just going to echo something that Samantha mentioned about the differences in the 2 ends of a power's field. The grain of our maps, I mean, even though we really have come a long way, we still can't map and model everything down to the smallest millimeter. So the grain of our maps can hide relevant information that is very, very local. And there is always a risk that we are missing something very local and very important. And this is why we really need validation from local experts who are familiar with the issues that are not being recorded elsewhere. So these are 2 of the things I think that when we communicate with those maps, we should be very clear about. And as to the spatial data sets and threat mapping in India, I mean, a few years ago, I would say having open access and license to use data sets, that's clearly not the case anymore. You will have access to a lot of information out there. But what is important is to have good coverage, good granularity and consistency. And this also brings me back to having metadata. I have the data for a certain indicator, but I don't know how that has been computed, where the data has been analyzed. It might be longitudinal data, but they might have had some methodological changes between the different phases of data collection. And sometimes this information is not readily available. And that makes me hesitant to use it because on the surface, it looks like extremely good data set, or perhaps it is the only data set that I can use. But then, that increases the uncertainty. So I guess those would be the some of the priorities for creating the threat mapping in India. Having some good quality input data to construct the threat indicators.
Yeah, that's great, Sarika. And I think you made two important points. One on the need for localization, which Sam was also pointing out, and the other on the data gaps and the fact that even if there are data, sometimes we don't know how reliable they are. And so we still need to close those gaps to be confident with what we're putting on a map. Thank you very much, Bruce Langford, for the first question in the question answers list. And actually, it's a very important question. So I think this is for Federico and also perhaps Samantha. Bruce is pointing out that fine scale differences between objectives can be important. And for example, the extent to which a decision in one field affects another, such as increased irrigation affecting water withdrawals and consumption availability in another field. But a NEXUS model, while it can capture the intersector trade-offs, they sometimes behave and do this post hoc. So the interactions are not, and the feedbacks are not part of the model. So the sectors are treated separately, and the submodels are not interconnected. And Bruce is asking, am I right in thinking that this is the case, that submodels are not fully integrated in the models that, for example, you're using, Federico? Or in fact, is there a level of integration that means that trade-offs are really well captured at finer scales? So I pass to you, Federico, first, and then maybe to Sam for her thoughts.
Yeah, one thing I totally forgot to mention in my presentation is that even at the national scale, we found some stakeholders coming from different provinces in the country or different regions, asking for more detail or more information specific to those realities in those provinces. Are just starting working on regional or provincial, in the case of Argentina, models for stakeholders, because most decisions are made at the regional level and not at the country level. Maybe the big policies are at the country level, and then the provinces or the states in each country, if they modify them and how they apply them. And even so, the food systems and the way of thinking of people in the different regions may also be different. So I think that modeling at the right scale and with the right definition or with the right level of ambition is crucial in this type of exercises. Besides, sometimes or most of the time, biodiversity does not correspond with the political boundaries, so we could even have problems modeling or maybe multiple modeling scales for every region or for every country. So it's a work in progress, and all critiques and all commentaries are welcome in that sense.
Okay, thanks, Federico. Over to you, Sam, for any reflections on that question.
Yeah, I think this is a really important point, and I think in my experience it is largely true when we're thinking about the larger scale models, the global models. Actually, it's a pet peeve of mine that I could rant on for hours about, so I won't, but is that especially actually land and sea interactions just are hardly ever accounted for. And how can we think about feeding the world when we actually don't understand the interactions and the impacts of gaining protein from the land versus the sea? That kind of really basic trade-off, we just don't have the information. But I'll just give one example that I think is probably the way forward. I was very peripherally involved in a modeling exercise called the Madingley model, which is a large process-based model that's been around for quite a while now. And it was pretty clunky when the first group of scientists released it. But what they did was, at that point, I think a really great step forward. They aimed to model all life on Earth and produce this virtual playground where we could understand these pressure response interactions. But of course, they didn't have that knowledge within just the small group that initiated this model. So they released the code, and I think open data, open code is so key to our work. And it was a wonderful response. So researchers around the world are saying, oh, well, actually, I know how that works. I can do that bit better. So I'm going to improve that bit of the model. And so all around the world, people are working on the specific aspects of the model that they know well, and actually improving that overall global model. So hopefully with more innovation like that, we really can get better at these interactions at the broader scales. Thanks.
Yeah, so a call for open source tools to help accelerate progress. I really agree with that one. Okay, we also have a question in the chat, an NGO based in the Gambia in Senegal. How can we work with you? Perhaps leave the panelists and the presenters to write their answers to that in the chat. And I think it's a good moment to wind up our discussions. And for me, some of the takeaways are that we need better data that's high resolution, has good coverage, has well-documented metadata on biodiversity and on ecosystem services that we can find in agricultural landscapes. We also need better tools, and to make sure these are using systems approaches, ideally capturing interactions, and ideally open source. And we need incentives for motivating behavior change. And some of these incentives could include capacity development to enable decision makers to understand how to use maps better in their work. So I have a very quick question to the panelists and presenters. Just answer very, very shortly. If you had to pick one priority out of the following four, which would it be for you? Sam shaking your head, I know it's hard. Better data, so closing spatial data gaps, better tools, improving our models, better communication from science to policy, or more capacity development? Which would you go for? Federico first.
I think that capacity development, I think that there are tools and there are data with different levels of resolution or better or worse, but there is a lot of information, and I think the capacity to know the already constructed models that are around, and to use them, and to use these models to interact with stakeholders is the key in most of the countries. especially in the developing countries.
Okay, over to Carolina.
Yes, I think going back to a question that was in the chat, if we have better models, but we're not working at the policy, institutional, and society level to get the integration of those sectors or the different dimensions that we're aiming to analyze with the models from a Nexus approach, then we're just going so far. But we really need to be putting all those other pieces in place also to really have more impact on the ground. That'll be my comment. Back to you.
Okay, great. Sarika?
Better data, better local data. There's just a lot of, using the example of our work, for India, there's a lot of data for certain components, but there's a lot of data missing for certain components. There's hardly any data on biodiversity. There's a lot of data on demography and some social components. So I would really like to see a lot of better data at more finer scales and spatial data if possible.
Okay, thank you. And Samantha?
Yeah, just to choose a different one from the others, I would go for better communication. I think not just between scientists and policymakers, but all the way up and down the chain, all the way from the ground up to up the chain. Yeah, communication is key.
Okay, so we've actually nearly chosen all of them, which shows that there's actually a lot of different things that we need to work on to help bridge this gap between making and generating spatially explicit products and them being really useful and used for decision making. So I think that's a key takeaway. So I'd like to thank the presenters and panelists for really high quality inputs. And thank our listeners as well for staying with us. We had 44 listeners, so that's great turnout. And our next NEXUS Gains webinar will be in August, and you can find the link to it in the chat. We haven't got the topic sorted yet, but please stay tuned. With that, goodbye everybody, and have a nice rest of your day.